Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, today we are going to discuss on polynomial regression. Yes, dear friends, polynomial regression is a regression algorithm that models the relationship between a dependent and independent variable as nth degree polynomial. Actually, it is also called the special case of multiple linear regression in machine learning because say we add some polynomial terms to the multiple linear regression equation to convert it into a polynomial regression. It is a linear model with some modification in order to increase the accuracy. And here, of course, yeah, dear friends, the dataset used in polynomial regression for training is of non-linear nature. So it makes use of linear regression model to fit the complicated and non-linear function and data set. And yeah, as I have already specified, it is a form of high-ordered linear regression modeled between the dependent and independent variable as an nth degree. So when coming towards this nth degree, yeah, let me just introduce some. Of course, I just want to give you small degree polynomial. See, for an example, if I just specify quadratic, okay, quadratic functionalities, yeah, you can just specify the equation as equal to y is equal to m1x. This is, of course, you all know, this is m1 as an slope or the constant, and here we can just go with to the power as like this is a quadratic equation we have already discussed in the previous sessions. And when you just go towards this cubic functionalities, yes, you can have not only this two constant, you are not able to have this two coefficient. We can just go with a few more by making as m1x and m2x to the power of 2, and even we are just extending with the cubic. That is what here we just get. And what about this nth degree? Yes, dear friends, we can extend this towards the high order degree variable of the same independent variable. And here you would have that equation as like m1x and m2 x to the power of 2, and here m3 x to the power of 3, till you can extend of mn and x to the nth power. Okay, and this is how we are just going to see it. And let me just create an functionality. I just want to show you in an Python functionalities. Let me just have an execution, and kindly just observe, dear friends. Here we are going to have an matrix functional as like line space. I'm just going to have a sample, 1000 sample, and the number it is going to be between -3 to 3. Okay, so here we want to have a plotting of totally 6 plots. We are just going to have it, and within 2 rows and each as like 3 columns. And under this, the first one, it would be a linear functionality, and the further things, it extends the degree as with degree 2, degree 3, degree 4, 5, and corresponding the 6th one. Okay, so let me just create it here, and of course, kindly just observe the visualization. And dear friends, when we just take on towards this particular functionality, I just want to specify, see, this is just to have an thing randomly. We took the values as -3 to 3, and we just took only 1000 samples. Let me just apply this to a data set. And here, yeah, we are just going to take a grade data set which we have already used, and yeah, this is having an set of students' average test grade score and their respective average number of hours studied for similar IQ students, which we have just seen previously. Let I just execute it towards linear regression. Why linear regression? Of course, we want to view it through the linear regression. Then I just specify what is the difference between this linear regression and towards the polynomial. Okay, so here of course we have already seen all these things previously and we have discussed in the linear regression part itself. Yes, dear friends, here I'm just going to plot it as scatter plot and let me have the correlation matrix out also, and I just want to create a regression to make the fit. Okay, and yeah, here we are just having the LR, that is the model to be fitted with X and Y, yes, the independent variable, and to the dependent variable of training data set. And kindly just observe, yes, this is what our data. So from our studies till we just have corresponding test grades, and we have created a correlation matrix also, and of course we are not able to get it here. Okay, fine. So let me just observe it here, dear friends. So we just got a exact data here, but let me just fit it in towards the data and observe how the exact data is. So when on applying it towards, kindly observe whether this is fitting exactly, How do you just specify, yeah, this is an exact fit towards the model, yes or no? And here I just want to specify one thing, dear friends, when on just specifying towards the correlation analysis, yes, what we just get here is, it is a relationship between the hour studied and to the best fit. And here when we just see, of course, we are able to get something as like 95% of R squared towards 97% of positive relationship here it is. And when you just see here we have up to this 4 hours of average studied, it is less than the 30 hours and it is not a perfect linear relationship here we just get. Okay, and although we can fit a linear line, and let me just apply this on to a high order polynomial regression. And I just want to specify one thing, dear friends, why we need a polynomial. See, dear friends, if we apply a linear model on a linear data set, then it provides us a good result as we have seen in simple linear regression. But if we apply the same model without any modification on a non-linear data set, then it provides a drastic output. See, due to which loss function will increase, the error rate will be high and accuracy will be decreased. That is what. So the error between these 2 points and here, and of course the 10th hour, here also our error rate will be high and the accuracy will be decreased. So for such case, where data points are arranged in a non-linear fashion, we need the polynomial regression model. We can understand it in a better way by using a comparative. So let I just give you the comparative study here. So yes, dear friends, kindly just observe. I just let you know here. So the same thing, if I just make it with a NumPy functionality and observe it, dear friends. So we have, yes, so note here degree 1, here is a linear fit. So it's in a blue color. And the higher order polynomial regression is fitting the curve better and R square jumps 4% at degree 3. Okay. And beyond the 3rd degree polynomial, there is not a massive change in R squared value. Okay, R squared value. So we can say that the 3rd degree polynomial is best fit. So see here, this is what I'm just specifying. This is degree 1, 2, 3, 4 and 5. Okay. So now how we are just going it towards this particular polynomial function. I just want to specify and make a revisit on which we have discussed in the session 16. the machine learning session 16. Of course, I have already discussed 8. So this is what, when we just get it ready with the data and the task. Of course, we have discussed what is the data. Of course, whatever be the data, whether it is a text data, audio data, or video data, or whatever be the data, kindly just know the 360-degree of about the data. Once you have collected or you are known about the data, kindly fix what is the task are you going to do with that data. Okay, now we are gone through this 2-step. And what is the next? Of course, we have to create a model. And the data consists of 2 parts. Of course, the input X and the output Y, and where X is the independent variable, Y the dependent variable. And dear friends, here, of course, I am just going to take an image as an input here, which is classified as a dot matrix because there is a function that takes the image and gives the output term. And here, yeah, what is the exact data? Yeah, we are labeling it as like an output, yeah, whether it is a bat or it is a car or it is a dog, like that. Okay, and of course, however, we doesn't know what is the exact function is, which can be problematic when using machine learning. And of course, dear friends, it is not a true function and it is a approximation functionality. Now, let me take an example of one-dimensional data with an X as an horizontal and Y towards the vertical. Okay, they construct a complex function such as X and anything towards cos of X or square plus or sine X or whatever be. So which is a well-defined mathematical function that represents the true relationship between this Y and X. However, the data doesn't know provides the function definition. Now, what is our model? Yeah, we are going to create a model. And in that model, yeah, we have just corresponding X and Y. We have plotted this data. And now let me connect it and have the functionality. Let me apply by creating a simple function that assumes the relationship between Y and X. Let me just take it as like a linear. So in such a case of linear, yeah, let me try to learn the parameters as M and C from the given data. But find the changes when adjusting these parameters. This is because the model cannot capture the relationship between the X and Y. So see here it is just passing to only few data points. So what happens? Yes, we realize that the function is not complex enough to capture the relationship between Y and X. Okay, now let me try more complex functions such as polynomial of degree 2. But they still fail to get the situation where the output of the function, kindly just see here, it is also crossing only the minimum data points, which is in the red color dots. What happens? Yes, dear friends, the machine's job is to efficiently find the best value of this A, B and C across all points, ensuring that the error is as low as possible. This is an impossible task for the machine as it is not complex enough to capture the true relationship between the Y and X. So it is still on towards fails to get a situation where the output of the function it's not never meeting or crossing a lot of the thing. So what it is? Yes, of course, dear friends. Now it is still on struggle with finding a suitable model for the relationship between Y and X. Let attempts to find a lower complex such as degree 3 polynomial, but fails to achieve the desired result still. Okay, so they continue to try increasing the complex function until they reach the 25th degree polynomial that is close to the function. Kindly just observe here. So the Benson's job is to estimate the parameter here as like A, B, C and D, and from the data ensuring that this green color curve is close to this red point previously, whichever. So however, in most real world scenario, visualization is not possible due to high dimensional data. Yes, we have to make this exact data towards the model creation, and we have to apply it on towards the data functionality. And here, dear friends, these machine learning scientists are responsible for creating model that explain or the model the relationship between this x and to the of y. Here I emphasize the importance of handling both the known parameter and the parameter built from the given data. Now let I just apply the same thing here towards this polynomial, and kindly observe, dear friends. So see here, I am just going to make use of this polynomial function, okay, to generate a new few matrix consisting of polynomial combination of the futures with a degree that is less than or equal to the specified degree. Okay, so let I just apply it here towards the linear regression previously which I have applied, that is the fitting towards the model. So that I just scroll it little. So here we have done. Okay, so this is what the one which we have just applied, made it fit, and now let I apply towards this. So here we go, and kindly observe the polynomial. So yes, dear friends, so I think actually here what we have discussed is we have just explored the essential role of model in machine learning, and we began understanding the relationship between this input x and output y. And of course, dear friends, we have discussed how this machine learning scientists approximate this relationship using various models, and looked at how model complexity influences this performance also. Okay, and yes, dear friends, we have understand these foundation concept, and of course we are just going to discuss more advanced topic in the upcoming with a project, end-to-end project. And I think this exact video would be helpful for you to understand the difference between this linear regression and to the polynomial regression, where to apply which functionality, and of course to be pointed again, I just specify due to the loss function with on increasing this loss function, which makes the error rate would also be high and the accuracy will all be decreased. So in such a case, yeah, we are choosing this polynomial regression rather than towards the linear regression. And yes, again, I just hope, I think so this video will be helpful for you. Don't forget to hit the like button. Dear friends, if you are not yet subscribed, kindly just subscribe the channel, and yes, make a turn on towards this notification, so you don't miss any videos that is upcoming. Okay, and yeah, drop a comment below, dear friends, if you have any suggestions or any comments or any doubts do you have. Yeah, let me take a session towards clarification, because so many are asking me personally, and I just want to give you a separate session related towards the doubt clarification also. And yeah, as usual, keep learning and stay curious. See you in next video, dear friends. Happy learning.